So when we start talking about, we're looking at the nutrient requirements of broilers, certainly a major change has occurred in this publication than the 1994. So you can see here that certainly we've kind of looked at this on a weight basis rather than age. And as the primary breeders, certainly these birds are, we're maintaining a 2 kilogram weight. It seems like shaving off a day every year. So certainly, as Dr. Kidd talked about, that we may be below 30 days of age with mature birds in the future. So that was kind of the thought process of coming up with a starter period up to about 600 grams, and then you can see finishing out to about 4,300 grams. So that's what the data that we really had to base some of this work on. As opposed to, you kind of see the age basis. So in terms of, I'll start out with amino acids. Study designs, really some of our criteria set forth really need to be deficient in amino acid, minimum of 6 treatments, but really like to see more, but needed at least 3 points to kind of meet that slope near the requirement, and then a couple of points beyond the requirement to hit a good break point. And then a minimum of 6 replications. We started out on a 10-year initially from 2007 to 2017, but just the delay of the publication extended this out to about 21. So just kind of bear with me on these next couple of slides, because we really took a different approach, and as I really was trying to sort through a lot of this data and create a whole new set of numbers for broilers with amino acids. So step 1 was to really took the total amino acid content of ingredients from the swine NRC. So that was a common set. Once we had identified some key papers that we were moving forward on amino acid requirements, we started out with lysine. And then we used a common set of digestibility coefficients, and with that, I reran every single data set that we were using on a common breakpoint based on this composition. So I did that for every different measurement, whether if it was body weight gain, feed conversion, as well as breast meat yield, so forth. So this took a lot of time to do this. So, but then we took these, the content of the ingredients, multiplied them by their inclusion rate, and then use these common coefficients. Then when we had a test, say for example, L-lysine was titrated, that factored in terms of getting a total digestible number across these different treatments. And so used, as you can see here, this reference on linear and quadratic broken lines. So if a linear fit that data set the best, I would use a linear. If it did quadratic, I used a quadratic, depending on the response. Due to a lot of significant gaps of amino acid requirements across the various weight ranges that I presented on the very first slide, it was very difficult to make significant changes other than lysine. So what we ended up doing was, once we established the lysine requirements, multiplied them by digestibility coefficients, and that were reported in the literature to populate this table. So I feel very comfortable with this. Our digestible lysine requirements, they were based on broken lines that I created using data from 13 different data sets. Now, for each data set, the midpoint of the body weight range, so from initial to final, we'd take that midpoint, and I would use that as that would be the weight requirement for, say, digestible lysine as a percentage of the diet, also on a milligrams per day basis. So I know that Dr. Kidd talked about that earlier this morning, about we need to really start thinking about that. So We really wanted to do that. And so with these various 13 different data sets, I then took these requirements and then ran them through quadratic regressions from 108 grams up to about a little over 4,300 grams. By doing these regressions, was able to come up with a requirement for each gram of body weight of these birds. And so from that, we were able to summarize this in the table from, say, up to 600 grams. So we would have an average value for that and so forth for each of these different weight ranges. So it's a little different approach, very similar to the swine NRC, kind of their approach. I'm very comfortable with this. I think our R-square on those ending equations was about 0.99. So there's some gaps in there, and I'll talk about that a little later. But just kind of wanted to let you know, from an empirical standpoint, that's how this table will be populated when you see it. We did try an initial approach on a factorial model based on work out of Dr. Sakamura's lab, and so this is kind of our approach there. We did this for lysine from 55 grams to approximately 5,000 grams, basically with early and late developing broilers with males and females on the lysine requirement. So this is a start on some of our modeling with broilers, but certainly this needs to be expanded upon. In terms of future research on amino acids, certainly, there's some, as I mentioned, some knowledge, some holes in the literature. We need more research on requirements from, say, from hatch to about 330 grams, very early on, as well as from 1,400 to 2,400 grams is another big gap, and then from 3,600 grams onward, there's another gap. So these are three major gaps that I saw through looking at the lysine requirement data. Certainly we need to look at the ratios. We've done a fairly good job with isoleucine, but certainly there's a lot of more work that needs to be done with arginine, but it's very multifunctional, as some of you know in this room, as well as tryptophan requirements, because particularly if we go to reduced protein diets, we're going to need to know more of this moving forward. And then just understanding these branch chain relationships is very, very important. And then can't understate modeling and gaining a better understanding of what's going on in commercial practice on feed intake and growth rate on a daily basis. We need that to move forward with our models. Now I'll switch over to minerals. Since 1991, our committee, and led by Mike's efforts, looked at altering our mineral requirements, and Mike's kind of touched on some of this. Really it was a lot of these papers are having an impact on economic relationship. For example, phosphorus, or displaying a deficiency in practical field type conditions. So, a lot of the limitations our committee experienced was really just related to bioavailability of minerals. We don't really have, experiments designed to appropriately look at mineral requirement studies. So that was, a big challenge for the committee. In experiments, oftentimes we really didn't have papers to justify a sole source change in minerals. So in many cases we were just confirming an older value a lot of times. So it's just this. I want to state this again. It's probably been stated, but this publication is only as good as the published research out there. But just to give you an idea, here's a table where, the minimum nutrient requirement recommendations based on experimental conditions may be changed. You see in orange from our 1994 report. Blue, these were really, these are just estimates. We don't really have sufficient experimental data, but and we've got that italicized in the document. But you can see that we certainly think that calcium recommendations need to be decreased across the board. Phosphorus as well, late in production. Otherwise, we didn't really see any changes from the other report. And once we got, the other report goes from 0 to 3, 3 to 6, 6 to 8. So then it was just a lot of these values were just carried through to on the weight basis. Micro minerals, we do have again some copper where we've kind of adjusted the estimate, well as we've increased the iodine estimate as well. Only iron, we had some justification to actually decrease that requirement. Manganese early on through about 600 grams, as well as zinc. But otherwise, you can see that we just did not have access to the data that we really needed to make some wholesale changes on minerals. In terms of what needs to be done moving forward, calcium requirements for these various weight classes, but we do have to have a good digestible model we can work with in terms of methodology of feed ingredients, as Mike said that in the previous presentation. In terms of phosphorus requirements, I think from 2,800 grams onward, we need more information there in terms of requirements. And then, growth and bone integrity has been used as our go-to in terms of criteria, but maybe we need to consider some other measurements such as immunity and metabolism as well as welfare moving forward. So Doug led the efforts on our vitamin work, and we really did not have a lot of data available to make changes. Data are just really sparse since the 94 edition. So you can see here vitamin D, we're able to make a change in the starter period, but really no other changes with our fat-soluble vitamins. Here we have our water-soluble vitamins. B12, we see some estimates that can be increased, but really don't have sufficient data to definitively say that we've got B12 requirements in these weight ranges, but otherwise we don't have any changes. D3 has been researched more than any other vitamin since '91. That's no surprise. I mean, a lot of sources of vitamin D determine that, but determine the requirement per se, the data's just not there. Choline's another one. There's 4 studies that have been published. They're very inconsistent. So we've just got to have some more data with choline, and particularly on these heavier birds there. Folic acid, there's some evidence that methyl donors, if they're limiting, then that can impact that requirement, but still, we just have insufficient data. So, as I said before, we've really looked at growth, but maybe we need to look at immunity and metabolism moving forward. So in summary, a major change is expressing requirements on a weight basis, and also we've added milligrams, on intake, particularly on amino acids. So I think that's been a nice change. Amino acid requirements, they were based on regression equations on the lysine requirement, and then the requirements were expanded on through ratios. We need a non-phytate phosphorus requirement beyond 2,800 grams for broilers. Again, digestible and phosphorus requirements need to be worked on in the future, and not really a lot of change really on the vitamin requirement data. It's just very, very sparse. So exactly what Doug was mentioning. So that concludes the broiler report.